This one says a ball of radius 17 has a round hole of radius 9 drilled through its center. Find the volume of the resulting solid. So here's the answer we're looking for. So I'm going to draw this. I probably can cut that off. So let me go here. So what we have is this, think of it as a semicircle that's going to be rotated around the x-axis. And what colors can I change this to? I'll leave this for now. Then what we have is right along here. Or maybe it's a solid line. We have y equals 9. And then this is a circle with radius 17. So this is 17 up here. This is 9 here. And the formula is x squared plus y squared equals 17 squared, or x squared plus y squared equals 289. So if we want to find out, we're going to use this in a second when we integrate it. We want to find this intersection point and this intersection point. And so if we say x squared, I'm going to go change back to blue because I prefer blue. X squared plus y squared equals the 289. And then we know what y is 9, so x squared plus 9 squared is 289. So x squared plus 81 is 289. So x squared is 208. So x would be the square root plus or minus the square root of 208. So that means that here is 208. Sorry, the square root of 208. And right about here is negative square root of 208. That gives us where we're going to integrate from. So it's just a fast forward, 0 to the square root of 208 would give us, well, I should say, negative square root of 208 to positive square root of 208. But because it's a symmetrical thing, I like to just do, it's going to be a pi out front. I'll do 2 pi integral from 0, to the square root of 208. Okay, so now we've got to set up the part inside that we're dealing with. And what we have is, since it's a circle, we need to solve for y. And we need to make it say y equals. So if we have our x squared plus y squared equals 289, subtracting the x squared, y squared equals 289 minus x squared. So y would be plus or minus the square root of 289 minus x squared. And since we're dealing with the upper half, and that's going to be rotated, we'll just go with y equals the square root of 289 minus x squared. And so that provides us this upper part of the circle. That gives us this portion here. And then we have to take away the part down here. So that's just going to be y equals 9. So this would be our capital R of x. This would be our little r of x. So it's going to be the square root of 289 minus x squared minus 9 squared dx, or 2 pi times the integral from 0 to the square root of 208 times 289 minus x squared minus 81 dx, or 2 pi times the integral from 0 to the square root of 208 times 208 minus x squared. So if we integrate that, this is a 2. We have 2 pi times the integral from 0 to the square root of 208. Nope, I just integrated, Jeff. So, okay, so we have 208x minus x cubed over 3. And we evaluate this from 0 to the square root of 208. And we get the number 1, 2, 565.61102. How many places do I want to take this out to? 0241. And that's our answer. So if you get different numbers, realize, I mean, if the radius is, or if this, it's, if the radius is like 18 or 15 or whatever, you're just going to adjust it. And if the y equals 5 or 7 or something, you adjust it that way as well. But this is the general process for it. Look for the outer radius, the big radius, the little radius. Look for those intersection points. A little bit of algebra there. Okay, hope that helps.